Okay, this is the inscribed angles practice. Okay, so again, inscribed angles are angles where the vertex is on the circle. So you have two chords. So BA is a chord, CA is a chord. They meet at point A. So the angle that's formed by those two chords is on the circle. The vertex of the angle is on the circle. So here's our angle. Because the pen's off a little, it's hard to draw on the lines. So here's our angle. The vertex of this angle is on the circle. Therefore, it is an inscribed angle. So is it an inscribed angle? Yes, because the vertex is on the circle. Okay. If it is, we want to name the angle and the intercepted angle. So this angle, we can name it angle BAC, or CAB. Okay, and then we want to name the intercepted arc. So the intercepted arc is the part of the circle that is between the two rays of the angle or inside of the angle. So the intercepted arc is going to be BC. Right here, it's the arc that is inside of, let me do it in a different color. Okay. It's the arc that is inside of the angle. Inside of the angle. Okay, so that is the minor arc BC. So the inscribed arc, angle BAC is the inscribed angle, and arc BC is the intercepted arc, the arc that is in the interior, the points on the circle that are on the interior of the angle. Okay, number 2, here's our angle. K is our vertex. K is not on the circle, so this is not an inscribed angle. It's not on the circle, so it's not an inscribed angle. Okay. Number 3, X is our vertex, so here's our angle. Okay, X is our vertex of our angle. X is on the circle, so yes, this is an inscribed angle. The name of this angle is VXW or WXV, angle VXW, or we could name it angle WXV. And then we want the intercepted arc, so that's going to be the arc that is on the inside, or in the points on the circle, the arc that are formed by the points on the circle that are on the interior of the angle. So in this case, that's going to be VW, arc VW. This is the intercepted arc, and this is the inscribed angle. Number 4, M is the vertex of our angle. If we notice, M is it's the center of the circle. So the center of the circle is not part of the circle, so it's not on the circle. So this one is no, M is not on the circle. Okay, but that is a central angle, but it's not an inscribed angle. It's a central angle because M is the center of the circle. The vertex is the center. So M is a no. Okay, 5. Well, let's do 2 at a time. Okay, 5 and 6. We want to find the measure of the arc or angle indicated. So in number 5, we are looking for this angle down here, angle A. Okay. We know the measure of, here's our angle, angle A. Okay, so that's our angle. It's an inscribed angle because it's on the vertex is A, and that A is on, point A is on the circle, so it's an inscribed angle. So the points on the circle on the interior of the angle that is the intercepted arc. So BC is our intercepted arc. The measure of BC equals 80, because it tells us. And we know the measure of the angle, so angle BAC, is going to be half of the intercepted arc. So that's going to be 80 divided by 2 is 40. All we're doing is dividing by 2. The measure of the inscribed angle is half the measure of the intercepted arc. Number 6. This time we're given the inscribed angle. So X is on the circle, and x is the vertex of angle WXV. So the measure of angle WXV is 42. So we want to look at the inscribed angle. Measure of W, okay, and so the inscribed or the intercepted angle is WV. So we want to find the measure of WV. Okay, that's going to be double the measure of the inscribed angle. So 42 times 2 is 84. Double the measure of the angle is, or the measure of the arc is double the measure of the inscribed angle. Number 7 and 8. Okay, so this is where people started getting a little bit confused, but let's look at, let's just stick to the basics, the vocab here. So we have an inscribed angle, or let's look at this angle, that's 35. Okay. Point E is the vertex of that angle, angle FEP. Okay, so let's highlight the angle. Let me, yeah, this is off center. Okay, so there's our angle, angle FEP. It is 35 degrees. Okay, so it's an inscribed angle because E is the vertex and it's on the circle. So if we look at the arc, the intercepted arc, the points on the circle that are in the interior of the angle, that's going to be arc FP. That is going to be twice the measure of the inscribed angle, so that's going to be 70 degrees. Okay. We, though, want to find the measure of arc. Is that a PD? PD. Okay, that's what we're trying to find. Right, so let's see what else we know. In these problems, one thing we can look for is the whole. We know the whole measure of the whole circle is 360. So all the arcs added together, or all the angles in the middle, add up to 360. 360 degrees is a circle. We also know half a circle is 180 degrees. Here we have a semicircle, FD. So FD here is, okay, this piece right here. That's a semicircle. FD is the diameter. That is a semicircle. So we know the measure of FD is 180. Okay, 180. Is that color okay? Not really. So the semicircle here, FD, is 180. So now we want to find this piece here, PD. So to do that, we're going to do 180 minus 70, and that's going to give us 110. So 110 plus 70 degrees. 110 plus 70 equals 180. So we knew this was 70 because this is an inscribed angle. So the intercepted arc, FP, is twice the measure of the inscribed angle. So that's going to be 70. Then we knew arc FD or FPD. The measure of arc FPD was 180 because it's a semicircle. Okay, then we can do 180 minus 70 to give us 110. Number 8, two different ways we can do number 8. Let's start with the arcs. So here is so D is a point on the circle. So if we make an angle, CDB or BDC, here's our angle. It's an inscribed angle, so we know the measure of the arc is going to be 98. We use blue here. Okay, we have another angle here at C. Okay. So on this angle, this is 70 degrees. So here's our intercepted arc. Okay. So that's going to be 140. It's double the measure of the inscribed angle. Okay. So we now have this blue piece and this red piece. Okay, so we can now find the measure of arc CD here. Okay, because we know all three of those are going to add up to 360. So if we wanted to call this x, we would have x plus 98 plus 140 equals 360. So x plus 140 plus 100 is 240. So this is 238 equals 360. We minus 238. We get x equals 122. 122 plus 98 plus 140 is 360. So it's all the way around. You don't need to write it out like this. You can just do 360 minus 140 minus 98 gives you 122. The other way we could have done this problem is we know the three angles of a triangle add up to 180. So by the Triangle Sum Theorem, so 180 minus 70 minus 49. That's 110 minus 49, 61. So we know this angle, angle B, is 61. That's an inscribed angle. Okay, that's an inscribed angle. So we know this is going to be 61 times 2, which is 122. That way is actually probably faster, but this one's more consistent with what we're learning right now. But both are great. They'll get you 122 either way. 9 and 10. So 9, a little challenging, I think, but let's work through it. Okay, number 9. So here's our angle. Let's start with start here. So let's look at angle V. Okay, so here's the angle. Okay. Here's angle V. Okay. Let me draw it a little better. Okay, so there's our angle. It's a pretty big angle. It says it's 120. It looks like it's probably more. But it's fine, 119. So we know this is going to be F, major arc, FGH. So FGH. Right, that is going to be our, let me write it here, measure arc FGH. Okay, that is going to be our intercepted arc. So that's this arc right here. This is our intercepted arc. We know that's going to be double the inscribed angle. So we know that whole thing, this whole thing here is going to be 119 times 2. So that's what, 120 times 2 is 238. So we know this whole thing is 238. Okay, we know this piece here, okay, arc GH. So the measure of GH is 168. Okay. We need to find FG. Okay. So to do that, we're going to do 238's the whole thing. We need to subtract. Well, let's do it in the right color here. So 238. We're going to subtract 168, and that's going to give us 70. So we know this right here is 70. So the measure of arc FG is 70. All right, so far so good. So what I'm going to do is I'm going to erase what I have drawn here. Okay. You always go back in the video. All right, and now let's look at a different arc. Our angle, let's look at angle VHG. So let's look at this angle. Okay. We found out that this was 70, right? Okay. All right. Our intercepted arc here is going to be VG, so the measure of arc VG, okay. Measure of arc VG is going to be double the inscribed angle. So the inscribed angle is 65, so that means that's going to be, the whole thing is going to be 130. Okay, 130. Okay, we had found out from using the 119 over here that this was 70. So we can do 130 minus 70, and that's going to give us 60 degrees. So this arc right here, right, has to be 60. 60 plus 70 is 130. So the measure of arc VP now is going to equal 60, which is what we're trying to find. Okay, so we took in, let me just kind of, all right, let me just kind of start over here. So we looked at this angle here. So we knew this whole thing was going to be 119 times 2. Right, here's 119, so here's the angle. So this whole thing was 119 times 2, 238. We knew this was 168, so we did 238 minus 168, and that got us 70. Okay, and then we looked the other way. We looked at angle 65. Okay, and we said 65 times 2 is 130, so the whole thing is 130. From the other side, we had found this was 70, so 130 minus 70 gave us 60. So our missing piece was 60. Maybe there's an easier way, I don't know, but that's the way I'm seeing. 60, that's the only way I can see to get there. Okay. Number 7, or what is that, 9? Number 10. So the one thing we have here for number 10 is we have angle, this angle right here. Okay, let me erase this. So we got 60 as our final answer there. Okay, so here's our angle. So here's our 95 degrees. That means that this arc is our intercepted arc. So the inscribed angle is 95. So the intercepted arc is twice the inscribed angle. So 95 times 2 is going to be 190. Okay. We know that arc SR here is 75. And therefore, we have the information to find our missing piece. So we know 360 minus 190 minus 75 is going to give us arc SQ, because we know that a circle is 360 degrees around. So 190 plus 75 will give, we want to call this X, do it the other way. X plus 75 plus 190 equals 360. X plus 265 equals 360. Subtract 265. You get X equals 95. And this is 265. Okay. So X is 95. The other way, also, I mean, same thing. We're just subtracting 265. That's going to give us 360 minus 190. Again, it's 170. 170 minus 75 is 95. So the whole thing adds up to 360. 11 and 12. We're doing on time. 20 minutes. Okay, 11 and 12. So you guys have plenty of time to finish in class today to get up to number 12. Because, I mean, we're taking our time explaining all these in detail. All right, I want to solve for X. Okay, so the first thing I want to do here is look at our inscribed angle. So here's our inscribed angle. Okay, so if that's our inscribed angle, we know that KRQ, our KRQ is going to be 110 times 2, that's 220. Okay, we know KP is 50, and we know 30x is this arc. So we have QP arc, QP is 30x, the measure of arc QP is 30x, the measure of PK is 50, and the measure of arc KRQ is 220 because we have an inscribed angle, and the intercepted arc is twice the inscribed angle. So now we're going to have 50 plus 220 plus 30x is going to equal 360 degrees because a circle is 360 degrees around. So that's going to be 270 plus 30x equals 360. Subtract 270. 30x equals 90. Divide both sides by 30. We get x equals 3. Okay. We had 50 plus 220 plus 30x equals 360. Okay, we're just adding all three together. Okay. I just don't want this so close to the other one. All right, this one, here we have an inscribed angle. So G is on the circle. So we have an inscribed angle. Okay, our intercepted arc, we know the intercepted arc is 190, 192. So the intercepted arc is twice the measure of the intercepted arc is twice the measure of the inscribed angle. So if we take 190 divided by 2, or 192 divided by 2, that's going to be 96. So we know the measure of the inscribed angle is 96. We also know it's equal to 31x plus 3. So all we do here is 31x plus 3 equals 96. Or we could say 31x plus 3 equals 192 divided by 2, which is going to give us 31x plus 3 equals 96. Same thing. Okay. Subtract 3. 31x equals 93. Divided by 31. We get x equals 3. 13, 14. Oops. I was about to ask if there were questions, but obviously no one's here. 13. Find the measure of the arc or the angle indicated. Okay, so we got to find x first, and then we have to find, so they want the measure of angle NLM, that's going to be this angle right here. So to find that, we're going to probably have to find x to find the measure of arc NM, and then we can divide by 2 because the inscribed angle is going to be half of the intercepted arc. Okay. But again, one thing we're looking for here are semicircles, and yes, we have a semicircle. So arc NML is half of a circle. So we know that 13x minus 10 plus 7x minus 10 is going to equal 180. Okay. So we have 20x minus 20 equals 180. We can add 20 to both sides. So we get 20x equals 200. Okay, divide by 20. And we get x equals 10. Okay, so we can substitute that in. 7 times 10 minus 10. 70 minus 10 is 60. That's not our final answer, though. We aren't looking for arc NM. Right, so this is 60, right? The measure of arc NM is 60. we're looking for the measure of angle NLM. Which is going to be half of the intercepted arc, which is going to be 30. We're going to divide 60 by 2 is 30. The measure of the inscribed angle is half of its intercepted arc. All right, number 14. Find the measure of arc FGH. So let's look. So FGH. Okay. And then we also have FAH. Okay. So if we look at angle G, right, here's our intercepting arc for angle G. Okay. We know the distance of this is going to be twice the measure. So this is a inscribed angle. Here's our intercepting arc for this angle. Okay, we know it's going to be twice the inscribed angle. So we know this one's going to be equal to 2 times 21x minus 2. Right, inscribed angle is half of the intercepted arc. So to get, if we have the angle, we need to multiply by 2. 30 times 2 is 60. 21x minus 2 times 2 is going to give us 42x minus 4. Okay. Here is our inscribed angle, angle A. Okay, and so here's our intercepted arc. So we know this is going to be twice the intercepted, or twice the inscribed angle. So we know this whole blue one here is going to, let me erase this so we're not confused. Okay. So here's our inscribed angle. Okay. So our intercepting arc is here, and that's twice the inscribed angle. So that's going to be 2 times 38x plus 5. Okay, which if we distribute is going to be 2 times 38, that's 76. And then 2 times 5 is 10. So 70x, so this, the measure of this arc is 76x plus 10. The measure of this arc is 42x minus 4. We know those two arcs together are going to be 360 because the circle is 360 degrees. So we can set the equation 76, let's do it in black. Okay, 76x plus 10 plus 76x plus 10 plus 42x minus 4 is going to equal 360. These two arcs added together equal 360. So that's 72 plus 42. That's 78 plus 40, which is going to be 118x. 10 minus 4 is plus 6. Equals 360. We can subtract 6 from both sides. So 118x equals 354. And that's probably 3. So divide by 118. 118, yep. 18 goes into 54 3 times, and 100 goes into 300 3 times. So we know that's going to be x equals 3. Okay. We want to find the measure of arc FGH. So we got to plug it into 76x plus 10. So 76 times 3 plus 10. 76 times 3. So 75 times 3 is going to be 225. So then we have to add 3. So 228 plus 10 is going to be 238. 76 times 3 is 228. Plus 10 is 238. If we want to just check our answer, we said this one was 42x minus 4. So 42 times 3. Whoops, 42 times 3 minus 4. That's 126 minus 4 is 122. 122 plus 238 That's 40, 60, 360. Yep. So we know we got the right answer, 238. Okay. That's 14. 15 and 16, I think, are pretty difficult here. I didn't realize that there was a y in there. So that's my bad for putting these on here, but that's all right. It's good practice. Okay, we want to solve for x and y. So we're just solving for x and y here. But we're going to end up having to have two sets of equations. I didn't realize there was a y here when I assigned this stuff. So, sorry, I made these 2 extra credit, 5 extra credit points, formative on your assignment. So if you come to the video or you know how to do them, then there's 5 extra points. Okay, let's do it. So, again, this is just like 14. Okay, if we take half an arc here, so if we take this angle down here, okay, and this angle here, okay, we now have an inscribed arc. The length of that is going to be 2 times 16y plus 6. Y plus 6, which is going to be 32y plus 12. So this is going to be 32y plus 12. Okay, and this one here, this angle, is going to give us this intercepted arc, which is going to be 2 times 10x, which is going to be 20x. Okay. And that's a full 360 degrees. So we have the equation here, 20x plus 32y plus 12 equals 360. We move the 12 over to the other side. We have 20x plus 32y equals 348. Okay. We have 2 variables in that equation, so we can't solve for either one. We need to come up with a second equation. Luckily, we have 2 more inscribed angles, so let's look at those inscribed angles. I'm going to erase all of this. Okay. All right. So let's look at angle M. It's hard to draw a straight line in here because it's not exactly where the end of the pen is. I'm off to the right a little bit. All right, so that's 10x. So here's our intercepted arc. That inscribed angle is 10x. The measure that inscribed angle is 10x minus 6. The inscribed arc is twice. So that's going to be 2 times 10x minus 6, which is going to be 20x minus 12. Okay. Then x, angle x here. Here is angle x. That's an inscribed angle because x is on the circle, which means it's an inscribed angle. Okay, here's our intercepted arc, arc LN. So that's going to be twice 4 plus 18y. So twice 4 plus 18y, which makes it 8 plus 36y. Okay, and here again, this arc plus this arc is 360. Okay, so we're going to get, let's write it over here. Okay, we're going to get 20x minus 12 plus 8 plus 36y equals 360. So we get 20x plus 36y equals, or minus 4 equals 360. So we're going to get 20x plus 36y equals 364 because we added 4 to both sides. Okay. So if we put that next to our other equation, here's equation 1, here's equation 2. We have 20x plus 36y equals 364. Okay. I'm going to use elimination because I see two 20x's. Okay, so what I'm going to do is I'm going to multiply the first equation by -1. So if I rewrite the first equation here, we're going to have negative 20x minus 32y equals negative 348. Okay, add those two equations together. The x's cancel out. We get 4y equals, that's going to be 16. Divide by 4. We get y equals 4. Okay, so we solve for y. How do we solve for x? We have to substitute it back in. So either equation will work. Let's just put it into the first one. So 20x plus 32 times 4 equals 348. Okay. 32 times 4 is, so 30 times 4 is 120. 2 times 4 is 8. So that's 128. So 20x plus 128 equals 348. Subtract 128. We get 20x equals 48 minus 28 is 20. 300 minus 100 is 200, so 220. Divide by 20. We get x equals, so 20 goes into 105 times, so that's 11. 11 and 4. We can plug those all in and see if they work. This actually has the answers on it, I believe, so we can just check and see if we did it right. 11 and 4. So look at that. We are good to go. We can line it back up now. We can. Okay. Right. 16. So we're doing the same type of thing here as the last one. Okay. So let's. Right. I mean, I kind of don't think anyone's going to do this, but you know, if someone out there is doing this, that's great, and I will help you if you need help. All I want to do is help people. You know, most people don't want to be helped, though. Okay, and the people that you can help don't need your help. So, got to get a PhD and teach college kids because they all want your help because they're paying for it. All right, so that's 2 times 6x minus 10, which is going to be 12x minus 20. Looking for the blue here. And I didn't realize these problems were like this, these last two. So double that, that's going to be 4y plus 200. Okay. Got to distribute the 2 out. So here again we have 12x minus 20 plus 4y plus 200 is going to equal 360 all the way around. Okay. So 12x plus 4y, that's going to be plus 180. So we're going to subtract 180 from both sides. So that's going to equal 180. 360 minus 180 is 180. Okay, and then we can erase all this and do the other equation now. Okay, red. So here's one. Okay, here's our intercepted arc. So that's going to be 4y. Look, our 4y's are going to cancel out, I bet. 75 times 2 is 150, so that is 148. Okay, because we doubled it. Then here's our other angle. Here's our intercepted arc. So this is going to be 14x plus 2. Okay, times 2. Okay, so our equation here is going to be 4y, let's start x first, 14x plus 2 plus 4y plus 148, again equals 360, it's all the way around. So 14x plus 4y. Was it positive? That's 150. So 360 minus 150. We're going to subtract 150 from both sides. It's going to give us 210. Okay. I'm going to multiply. So 210. So let's use our first equation first. 14x plus 4y equals 210. Then I'm going to multiply the second equation by -1. We get negative 12x minus 4y equals negative 180. We add those two equations together. 2x, the 4y's are going to cancel out. 2x is going to equal 30. Divide by 2. We get x equals 15. Substitute back in. So either one would work. Both are probably 14 times 15. So let's plug it in here. 14 times 15 is going to be, oops, I don't know. What's 15 times 15? 225, so 210. 210 plus 4y. That's not. Yeah, maybe it's 0. I don't know. Let's try it. That's 20. That's 6. That's 15. That's 210. So that's going to be y equals 0. Minus 210, 4y equals 0, divided by 4y equals 0. And we can just check, see if we screwed something up or if we were accurate. Y is 0, x is 15. Look at that. Sometimes I know what I'm doing. All right, so there we go. 15 and 0. Yep.